Welcome. In this video, we're going to look at yet another good example or another question under rotational motion. And in this video, we have been given this diagram which has this disk and the radius is 0.3 meters, and this one, the mass is suspended from this disk, and we are told to say it falls a distance of 3 meters, and the question demands us to find the mass of the disk if this mass was this distance. So from this point, it is so much important that we look at the additional information. So the data, mass 4.2 kg, radius, this one, then height 3 meters, and time seconds. Now, just as we did in the previous video when we were looking at conservation of energy, we know that PE, conservation of energy, from the principle of energy conservation, PE is equal to KE total, of which we know that PE, as it is coming, it is rotating again, covering some linear distance. So we have KE rotational plus KE translational. Rotational kinetic energy and the translational kinetic energy. So from this, PE, potential energy, the formula is mgh, which is equal to rotational kinetic energy is given by half a moment of inertia, omega squared, plus this one, it is half mv squared. So from this point, we can proceed as follows. We know that for a solid disk such as this one, the moment of inertia is half m r squared. So this is the moment of inertia. Moment of inertia for a solid disk. And at the same time, we know that omega is equal to V over R. So putting this one and this one in this equation, we are going to have times I, which is 1 over 2 m r squared. Then we have for this one, so we say V over R. Okay, we put capital squared plus half mv squared. So from this point, we have mgh is equal to, so half times half is 1 over 4 big M R squared V squared over, so this one R squared, it will be R squared like that one, when this one is squared, plus half M V squared. But this one and this one can cancel, and what we're going to have is mgh is equal to 1 over 4 m v squared plus half m v squared. So this is capital M. So from this, V is common, you can factor it out. mgh is equal to v squared m over 4 plus m over 2. So this one we can divide it through by v, also here by v squared, by v squared, and also here by v squared. So that we have mgh over v squared. So this one we're going to have factor m over 4 plus m over 2. But we want to find the mass of the disk, which is the big M, so we can subtract this from this. When this crosses the equal sign, we are going to have mgh m over 2 is equal to m over 4. from this point, we want to make M the subject, so we can multiply through by 4. Okay, so by 4 here, also here by 4. So here what we're going to have is M, 4 and 4 will go. So we are going to have M is equal to 4 mgh over v squared minus 4m over 2. So here we are going to have 4 mgh over v squared minus 2m. This is m. Now we have the value for m, which is 4.2. We have g, we have h, but we do not have v. So from the information that we were given, we need to find v. But in order for us to find v, we need to have acceleration. So that we put it here, or put v here in order to figure out this. So we know from the equations of motion to say x is equal to ut plus half at squared. Now, since the body is coming from rest, this one will be 0 plus half at squared. X is equal to. So this is the same as x is equal to half at squared. So that this one will be 2x when we do this, we cross multiply, is equal to 8t squared over t squared over t squared. So our acceleration will be 2 times. So we're going to have this one will be 2 times displacement 3 over the t squared. We have 2 squared. So 6 over 4, which will give us 1.5 meters per second squared. So this is our acceleration. But we need to find velocity. We know again to say v is equal to u plus at, where u is equal to 0 plus our a 1.5 times t, which is 2. So we're going to have this one will be 3 meters per second squared. The same can be worked on, can be found when we use v is equal to u squared plus 2ax. So u is equal to 0 squared plus 2 times 1.5 times 3. This will give us 9. So the root of 9, v is equal to the root of 9, which will give us 3 meters per second. So when we put this into this, m is equal to, so let us plug in the values. We have 4 times the mass, 4.2, times the value of g, 10 or 9.8, times the height, 3 over 3 squared, everything minus 2 times 4.2. So here, what we're going to get is 46.48 kg as the mass of a disc. Thank you so much for watching the video.